game over. Okay, thank you. Sometimes I can be wrong, or most of the time. So whenever I'm wrong, you are correct, you get a pint. Okay, but if I'm right, you are wrong, I get a pint of orange juice. Okay, over pi c cube. Okay, right. So now we have everything. So how are we going to combine this now? Okay, so we're going to now sketch element C. Okay, we're going to sketch element C. So if I'm going to sketch element C will look like this. So I'm going to do this as my transformation now. Okay. Okay, so this is our transformation. Exactly the same as our diagram. So element C is at the bottom, right? So bottom, you will have a curvature like this. Okay, this is our element now. Okay, so we know in element C, we have a compression, right? We have a compression in stress X, right? So we have a compression in stress X, right? And based on how the top is rotating, right? The shear will be in this direction. Okay, the shear is going to be at that direction. Okay, so this is our shear. Okay, so this is our shear. So the shear is acting on the intersecting plane X, and the direction is in the Z. Okay, so those of you that did 3CO3, you should remember this. So the X down here is the intersecting plane, and Z down here is the direction of shear stress or shear force. So this side, this one is shear ZX. Okay. So anything else acting? No, we have nothing else acting. So I'm going to draw this in a way that you're more more familiar. Okay, I'm going to draw this in a way that you're more familiar. Okay, so I'm going to reorientate the transformation now. So I'm going to call this my X, right? Then I'm going to call this my Y, and then this direction is my Z. Okay, so I'm going to draw the element in the orientation in 3D now. Okay, so which you are more familiar. All right, so this is our stress X. Right now, you guys are more familiar in what you're seeing now. Yes or no? Right? And then when I orientate, so oh God, good morning, Eugene. So this is my stress X, and then my shear. So this is how my shear stress will look like. Okay, so this is my shear. So it's intersecting the plane X, and this is going to be in the, oh, no. I. Hold on, people. I think I labeled this one wrongly. Yeah, I labeled this wrongly. I do apologize. So this is Z and this is Y. Now this makes sense now. Okay. And this is shear. The intersecting plane is Z and this is the X direction. Okay. So now this looks familiar to you guys now. Okay. So from here, we're going to label this element now. Okay. So what we've just drawn is an element. So I'm going to label this on based on the face. This is point X. This is going to be point Z. and this is my point Y. Okay, so this is, we are now going to construct, okay, we're briefly going to construct 3D Mohs circle. Okay, we are now going to construct 3D Mohs circles now. So why are we, so let me, can anyone tell me why are we going into Mohs circle? Anyone?
We want to find the maximum stresses possible on the elements.
You want to find the maximum stresses. You are partly right. Okay, I'm not saying that you're wrong. You're partly right. Okay, and it's not the maximum stress we're trying to, is you're partly right. Okay, it's the principal stress that we have to identify. Okay, but before that, let's construct Mohs circle now. Okay, let me give you a brief preview about 3D Mohs circle now. Okay, now 3D Mohs circle is not a sphere. Okay, 3D Mohs circle is still a what? A circle. Okay, don't think like, oh crap, we are going to draw a sphere now. No, 3D Mohs circle is still a circle. So I'm going to, you guys have done 2D before. I believe most of you have done 3CO3, right? So you've done 3CO3, you have seen Mohs circle before. Okay, so I'm just, this is just a sketch. Okay, so on the sketch, yeah, I'm going to draw, as I say, this is just a sketch. I'm just going to let you see what a 3D Mohs circle look like. Okay, so this is your normal stress, and this is going to be your shear stress. Okay, this is your shear stress. I don't hear anyone. I don't hear anyone saying like when I say 3D Mohs circle, you guys say, "Oh shit!" I don't hear that yet. Okay, probably you guys are doing in your bedroom at about 10:20 in the morning. Oh shit! Here we go again. I would have done that, for crying out loud. So clockwise rotation, anti-clockwise rotation. So if you look at the element, we're going to find point X now. So point X is going through compression. So this is as I said, this is just a sketch. Okay, so this is my point X. Okay, this is my stress X. Okay, and then my stress Y and stress Z, they have zero normal stress, yes or no? So if you look at the element, all right, stress X is equal to, we have a value for stress X which is equal to minus 2500 C minus 72,000 divided by pi C cube, right? So stress Y and stress Z is equal to what? 0. Okay, then we have a shear XZ is equal to shear ZX. This will be equal to minus 55200 divided by pi C cube. Okay, so when you have that, so we know that over here, this is where our stress Y and our stress Z are. Okay, then we start constructing a line. But before we go on, there's one point that we absolutely know. Okay, there's one point we absolutely know, and this point over here is your what? Point Y. Because point Y has zero normal stress and zero what? Shear stress. Okay, so next we are going to construct the shear stress line. Okay, so this is again just a sketch. So this is our shear stress line. So just to quickly recap, okay, so if you look at point X, right, the shear stress, right, the shear stress over here for point X is going to generate an element rotation in the what? In the clockwise direction. Okay, so from there, you know that this is your point X, okay, and this is your point Z. So from here, we're going to draw a straight line. Okay, from here we're going to draw a straight line. Okay, so after we have drawn a straight line, we're going to construct a circle now. Okay, so this will be, let me calculate, 3.6. Okay, so let's draw a circle now. Okay, so I'm going to sketch the circle now. This is just a sketch. It will not be a perfect circle. Okay, it never will be.
Professor,
Yes,
how do you know to label those specific points X, Y, and Z on Moore's circle?
because because at point Y, right, at point Y, the normal stress is equal to 0. The shear stress is equal to 0. Yes or no? Right. So point Y over here is this Y over here, right?
The
You don't
surface?
see. Hello?
Yeah, the surface.
Yeah. Okay.
Oh, okay.
Okay. The stress is 0. So if you look at stress Z, right, the normal stress is equal to 0, but the shear stress is equal to 55, 200 over pi c cube, right? And then your stress, oh, I should standardize this. Okay, Z and X is the one that you have all your stresses, right? Minus 2500 C minus 572.123 over pi c cube, and then you have the shear stress. Okay, by the way, in this class, don't call me Professor just call me Eugene. Okay, I don't like that formality, never will, and I should never want to. Okay, now back to here, right? So now this circle over here is a 2D Mohr circle, right? Next, we're going to construct the other two circles. Okay, so don't worry about it now. Okay, so how I construct the other two circles is from point X. Okay, so one, so this is the other circle. Okay, and then this is the other circle, and we have one more, 3, 6, 5. Hey. So it should be around here. It's not really round. I think it's my eyes. 3, 6. Okay. Okay. No. I think this is. I'll try to get it better. Okay. Let's not waste your time. Okay. Right. So this is known as a 3D Mohr circle. Okay. So this is our 3D Mohr circle. So now, once you have constructed this circle, we know that the maximum stress your element will experience in normal stress loading, okay, is your stress A, and over here at stress B. Okay, so we know from here, right, stress A and B are known as your principal stress. Okay, are known as your principal stresses. So now the next thing you have to know is how to find the principal stresses. So all this that you see, okay, all this that you guys are looking at now, okay, so what we have done today, right? So if I zoom out, okay, so what you have seen down here, okay, what we have seen down here, right? This entire thing that you see down here, I'm going to teach you on week number 5 and 7. Okay, you guys are going to learn this in week 5 and 7. Okay, and I'm not done yet. Okay, I'm not done yet. Okay, so the next thing, once we have the principal stresses, then we can compare to what? Then we can compare with material properties. Okay, from the handbook. So what you ought to see is the procedure. Okay, is the procedure that you are going to learn, that you're going to have the knowledge on how to design uh, uh, a workpiece, or how to design your structure properly. Okay, so you can see a lot of integration. Okay, integration. So I have about another like 20 minutes of intro to do. So I'm going to stop my class here. Okay, I'm going to stop my class here. Don't go yet.